Okay, let's see this equation. So on the left-hand side, we have a 4 raised by x plus 9 raised by x, 25 raised by x. On the right-hand side, we have 6 raised by x, 10 raised by x, plus 15 raised by x. So how do we approach this kind of question? The exponents are the same, but the bases are different. But however, the bases have certain relations. We see 4, which is 2 square, 9, 3 square, 25, 5 square. And on the right-hand side, we have 6. 6 is 2 times 3, right? So that relates with 4, relates with 9. 10 is 2 times 5. So that relates with 4 and 25. 15 is 3 times 5. So it relates with 3 and 5. So we like to write all the bases in terms of the factors, their factors 2, 3, and 5. So let's do that. So 4 raised by x, we write as 2 raised by 2x. 9 raised by x, we write as 3 raised by 2x. 25 raised by x, we write as 5 raised by 2x. And those three, we can rewrite as 2 to the x squared, 3 to the x squared, 5 to the x squared. So now we have a square terms on the left-hand side. On the right-hand side, 6, we want to split into 2 and 3. So 6 raised by x, we write as 2 raised by x times 3 raised by x. 10 raised by x split as 2 raised by x, 5 raised by x. 15 raised by x, we write as 3 raised by x and 5 raised by x. Right? So now, if this looks troublesome, you can think 2 to the x as a, 3 raised by x as b, 5 raised by x maybe c. So we have a squared plus b squared plus c squared on one side. Then what's on the right-hand side? We have a times b, we have a times c, we have b times c. Okay, then we think about perfect square formula. Perfect square formula, let's use this as example. 2x squared, 3x squared. That's a squared plus b squared, right? If we move this a times b to the other side, right, then you will make this 2. If we need, because we have 2, we have a times b, a times c, b times c. So maybe we want to do this. We want to multiply everyone with a 2. Because we need, because this middle term is 2 3s, we need 2 raised by x squared twice, because we have here, I'll have middle term 2 raised by x, 5 raised by x, right? Because you see each one appeared twice in the middle term. That means we need the square term, we need twice of the square term. So we multiply by 2. Then we move the terms from right-hand side to the left-hand side. Then we make the equation equal 0. So this is one crucial step for solving equations. A lot of times we want to make one side of the equation to be 0. Okay, we do here, same thing. So then now we can think about, we have a squared minus 2ab plus b squared, right? We have a squared minus 2ac plus c squared. We have b squared minus 2bc plus c squared. So 3 perfect squares. Then let's make perfect squares. 2 raised by x minus 3 raised by x squared. 2 raised by x minus 5 raised by x squared. 3 raised by x minus 5 raised by x squared. Now observe this. The right-hand side is 0. But the left-hand side, we have squares. And we are in real number system. We're not talking about complex numbers here. But in real number system. So that means in real number system, every square has to be at least 0. So this can only be 0 plus 0 plus 0 to be 0. So, right, in real number system, so every square has to be at least 0. Then in this case, they add up to be 0, so each one has to be 0. Well, each one has to be 0, that gives us 2 raised by x minus 3 raised by x equals 0. And basically 2 raised by x has to equal to 3 raised by x, right? And what kind of situation the left-hand side and the right-hand side to be equal? Only when the exponent is 0. because the bases are different, but the exponent are the same. And we have an equation. So the forces x to be 0 because anything raised by 0 to be 1. So basically we have 1 equals 1 equals 1 equals 1. So x is 0. Well, let's go back to the original equation. So in this case, you see 4 raised by 0 is 1, 9 raised by 0 is 1, 25 raised by 0 is 1. So I have 3 on the left-hand side. On the right-hand side, same thing. We have different bases. When they're raised by 0, there's only one value, 1. Okay, that is the solution for this equation.